So in this video, we are going to talk about the representation of the graph. How can we represent the graph, right? In previous video, we have discussed about type of graphs and we have discussed about 5 types of graphs. Now, the representation of the graphs. Now, first you need to know how many types of representation of it. Like how can you represent? There are nearly 3 ways that you can represent a graph. First one is as a adjacency list, right? And second as a adjacency matrix. Second one is adjacency matrix, and third one is compact list, right? These are the 3 ways that you can represent the graph. And in this video we are going to learn about adjacency list, and we are going to learn both using vectors and normal list, right? Normal data structure list. And for list I'm going to use HTL, standard template library. Okay, now let us start with the vector. See, vector and linked list are almost same, like how we represent. So let us start with adjacency list. Now if you can observe here, it is a non-directional graph because there is no direction. That means if 1 is connected to 2, then 2 is also connected to 1, right? So in directional graph, you need to remember that if you have a link like this, right, from 1 to 2, then that link is not from 2 to 1, right? It is from 1 to 2, it is not from 2 to 1. But in case of non-directional graph, if link is there between 1 and 2, that means link is from 1 to 2 and 2 to 1, right? Okay. Now, count the number of vertices that you have, and starting vertex is also important. Some start from 0, some vertices start, some graph starts from 1. So in our example we are starting from 1, right? 1. So okay, 1 2 3 4 5 5 nodes I have, no 5 vertices I have. So take this one here. So I have created a memory for 5. Now next thing what you need to do, their relation, right? 1 is connected to 2, right? 1 is connected to 2, 1 is connected to 2, 1 is connected to 3. Okay, 1 is connected to 3. Sorry, 1 is connected to 3, and 1 is connected to what? 1 is connected to 4. So 1 is connected to 4. So like that, I am going to go on connecting linked list, or you can say I am going to push back the elements in vector. That's it. Now again, 2 is connected to what? 1 and 3, right? 2 is connected to 1 and 3. Again, 2 is connected to 1 and 3. Like that I am going to represent. But let us see the space complexity here. So space complexity means how much memory that it is taking. So first thing first, that is you are definitely going to take 5 vertices. For that I am going to take V. Like V means number of vertices that I have. Next, there are how many links? You can count 1 2 3 4 5 6 7 links. But how many memory that you are going to store in order to represent these links? Yeah, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Why 14? You have 7 links, but you have 14 memory location in order to represent these 7 links. It is simple. It is a non-directional graph. That means from 1 to 2 what you have, right? From 2 to 1 you will have again the same thing. So same thing, same link you are representing twice, 1 to 2 and 2 to 1. So that creates twice, right? 2 into E means number of edges, number of links. So it can be given as like V plus 2 of N, right? Again, V can be taken as N, right? N plus 2N, it is 3N. It is nothing but big of N. So space complexity is big of N. Okay. Now, graph becomes important when there is a weight. What is meant by weight? See, from 1 to 2 I have a link. From 1 to 3 I have a link. So these links will have some weights. Weights means what? There is a weight from 1 to 2. That weight is 10. So there is 1 to 3 link. That link's weight is 100. So it can be random. It can be anything. So based on application, there will be weights here. So if you have learned, if you have heard about in ML, there is a neural links will come. Their weights become so much important. Similarly, the weight that is same. The link, there will be a link and it has a weight. Now, how to represent that? That is simple. I will show you for one. That means for one, I'm going to show, and you can write it for all. One vertex, right? Now I'm talking one vertex, and it is connected to what? Let me take this weight as 20. It is connected to 2, 3, 4. So write 2 here, right? 2 here. So this is the link that it is connected. That is the vertex that is it is connected. And what is weight? 10, right? And here we have a pointer that points to the next one. So again, it has what? One is connected to what? 3. Again, 3, and its weight is what? 100. 100. Now, it is connected to what? Connected to 4. So, I will write 4. Now, what is its weight? Its weight is 20. And null. Right? Like this I can represent. This is again, second thing. And now let us talk about the direction graph. Right? Direction. Because in code I am going to represent these all things. So, now, direction graph means what? See, let me write a direction for this. Let me draw another similar graph here. So 1 to 2, again 4, this is 3, and this is 5. Imagine I have like this, but it is a direction. 1 to 2 have, 1 to 3 I have, 3 to 1 to 4, and 3 to 4, then 3 to 2, 3 to 4, then 4 to 5, 5 to 6. I have like this. So how can you represent here, right? How can you represent this in linked list or a vector? Now take one. One is connected to what? 2, right? Normally same thing you are going to do. 2, and again one is connected to what? 3. And always remember, this. It shouldn't be in order. Like, it is not compulsory that it should come 2, 3, 4. It can be 2, 4, 3, anything. But what we are trying to represent is what are the adjacent nodes for this link. Sorry, what are the adjacent nodes for this node? That is what my intention. Adjacent node means what? It is simple. Sorry. Now, adjacent node means if there are two nodes that are connected. If there are two nodes that are connected, then they are called as adjacent nodes, right? Now again, 4 will come. For 2, what you are going to take? For 2, imagine this. Let me just, for example, I am going to change this question slightly like this. So for 2, is it connected to 1? Yes, it is connected to 1. But the link is not going from 2 to 1, right? So for that reason, you don't need to take 1. You need to take 3 because link is going from 2 to 3. So I will take 3. And again, there is nothing here. So I'm going to reduce this number of nodes and number of memories that are needed for directional graph. So let us see the space complexity here. So space complexity is again simple. Space complexity is V. Normally you need this for vectors, plus the number of space that you take here will be equal to number of edges, because once only the edge is represented only once. So n plus n, 2n. So it can be considered as big of n. That's it. That is what our directional graph. Now let us go to coding section. I need to code this thing, right? So it is using linked list. Let me do with a vector. So after that I will do with the linked list. Right now I will ask the user, how many nodes do you have? So right, how many edges do you have? EDG. Now I will ask the user to enter node and edges. Right? Then cin node and EDG edge. Now I'll ask the user, is it a direction? Because if it is a direction, then that will change, right? There I don't need to connect another link for that one, as you know, as I explained. So I'll ask the user, is it a direction? Directional graph. Now the person will enter a string, right? Yes or no? That is what I am expecting from him. So str again, for specification I can give that typing yes or no, right? Yes or no. If it is no, that means it is a non-direction. Now let us come here. So he has entered. I need to create a vector, right? I need to create a vector. So vector and int. I will call it as a vec. Then n plus 1 means node plus 1. Why node plus 1? See, first of all, you need to know whenever you create a vector, right? Imagine I gave it as a v, and in a common bracket I'm going to enter a number that is 10. That means create a vector of size 10. If you use common bracket, I'm not using common bracket here, I'm using square bracket. That means I'm creating a vector. It is like a two-dimensional vector. It is like a two-dimensional vector with node into node, row. So size of row and nodes are what? It is one. Sorry, it is the size of row and size of the columns are node plus 1. Why node plus 1? See, in this example, what I am doing is I am starting from 1. So if my nodes are 5, here 5, right? If nodes is 5, then it will take from 0 to 4. So where will be the 5 node? What it does? So it will become a problem for us. So I will neglect the 0th index in both rows and columns. So for that I am taking 1 year. After that, then I will go into for loop because I need to ask for the connection. What are the edges that you have from where to where? I need to know the edges, then only I can able to connect. So I will go like ask for that much edges, then I will get in here, then I will create some variable u and v, and I will ask for the edge, right? Starting node to ending node. Starting node value is what? That means I don't ask wait here. Always remember, I'm not going to ask in this code. I'm not going to ask wait for that. I'm going to ask just the starting node and ending node. If you tell me the starting node, like he will tell me one, okay, ending node two, okay, I need to create a link between them. That's it. That is what I'm going to do. So I'll ask him starting node and ending node. What is that? So enter the starting 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 node and ending ending node, right? After that, here enter me the node. So let me take the node here, u and v. Now after taking the node, what I am going to do is I will do this one vector of u. Since it is the two-dimensional vector, I can do push push back. Simply push back for u, push back v. Right? I'm going to connect it. For u, I'm going to connect v. Then I'll ask if str is it equal to no, right? Is it no? That means is it a direction, non-direction? If they give me no, that means what is it? It is a non-directional graph. For that, you need to connect on both sides, right? V dot pushback, back, the u, right? That is what I need to do. So I have created everything is over. Now I need to just display. That is my work. So let me take I is equal to 0, I less than. So node, right? I need to go till node, but actually I should start from 1. Because my node is starting from 1. So right, then I plus plus, then get inside. Then for int j is equal to. So for that I, that means j will start from where to where? That is my question. It should start from 0, actually 0. That means now I am in one particular node, means I am at this node, right? I need to go and traverse all this one, means 0 to I need to go till this. So what is this? This size, go till size, right? Size. Let me code, you will get to know. So from 0 to j is less than, what is that? Vec, right? I, right? Dot size. That's it. Go till there and you increment, then come inside. Before that, please print, first of all, you print that node itself. If you have printed the node, right, I will print the node. Then I can simply go on adding. Let me give some arrow mark here. Now I will give some space. Then okay. Now 0 to size. Now I need to simply print what I need to print. Vec at I and j, you print me and give some gap. Give some gap. Okay, I have give. Now, if I am going to run this program, I think it should work unless it has some compiler error. Okay, let me see what's the problem. Redefinition. I think I have not commented some code here. Let me drag this down. Like I have this. See, I need to comment this thing, right? This is my old program. Now, I think it should work now. There is some error again. Vector. I need to declare the library, right? So vector include. For vector, I need a library. Let me run. Let us see what all the error I get. Okay, enter the node and edges. I'm going to simply use this thing. I need to get this result perfectly. I need to get this result. So what I do is I will give the same question. Let us see whether I get on. Number of nodes is 5. Number of edges is obviously 7. Then is it a direction? No, it is not a direction. Now, starting node and ending node. Starting node is 1 and ending node is 2. Starting node is 1, ending node is 3. Starting node is 1 and ending node is 4. Then starting node is 2. From 2 I will go to 3. And from 3, where I can go 3 to 4, can I go? Yes, you can go. From 3 to 5, can you go? Yes, I can go. From 4 to 5, I can go. So, did I give all 7? Yes. Now see, I should give this C out here. I am doing this mistake so many number of times. I need to give this C out because it will be output will be visible just like what I solved. So let us quickly give all the inputs. So edges are 5 and 7 and no. Then enter the starting node and ending node 1 to where 1 to 2, 1 to 3, 1 to 4, then 2 to 3, then 3 to 4, 3 to 5, 4 to 5. Now, am I getting the same thing? See here. See here. Okay. 1, 2, 3, 4, 2, 1, 2, 1, 3. Okay, 3, 1, 2, 4, 5, 1, 2, 4, 5, 4, 1, 3, 5, 1, 3, 5, 3, 4. Yes, I am getting proper answer. Now, let us solve this thing. Again, if I give no here, yes here, then you know what will happen. Here 2 to 1 will not be created, right? 2 to 1 will be not created. You can check that one answer. Now let us quickly go to the linked list. So let us solve this same problem using linked list. So for that I am going to use some classes to be some revision if I use class and objects. So let me copy this comment here and let me comment this using linked list. Linked list. Now I have a include IO strn stream IO str stream. Then obviously since I'm using HTL, I said you already, and I need a list, right? List, because I'm using linked list. Then using namespace. So if you have any doubt whether sorry, so in HTL you can implement anything like maps, list, set, stack, queues. Any data structure can be implemented. It is so much easy. You can go to this website. Let me tell you that website. I think CPP reference. So if you type this, and in front of this if you type linked list like this, then it will give you all the features that you can use for linked list. So push pop, everything will come. So let us see what all I can use. Int main, then I will go inside. So before that I need a class. Let me call the class as graph, graph. So I have in private I have a v. Let me call it as v. That means the node, the vector, sorry, vertex, number of vertex. Okay, I need a linked list, right? I need a linked list. So let me take the list, list. Then it should be of int type, obviously. Then let me call it as a ADJ, right? ADJ. So let me take a pointer. Let me guess what will happen here. So I will take a pointer. Then public, I will go public, right? Now, after going public, I am going to call this through constructor. Let me give the number of vertices I have. The number of vertices I have, I will give through uh, the constructor. So let me call v. Since I'm using same variable, you can't simply do like this, right? You can't simply, you need to use this. If you use it, will work. Now what you need to, or else if you don't know what is this, you can simply do this one. You can take the variable as a, and for v is equal to what, v is equal to a, right? That will also work. So here it is v, so I need to fill this value as the thing that I give in int main. You know how it works. If you don't know, you can solve this normally, because I already said you how it is solved using vector. So it is so much simple that you need to replace this vector by list, and there some modification you need to do. That's it. But for class and object, I am trying to make you revise this concept. Now, okay. Now ADJ adjacent should be equal to new, right? New. I have created a pointer. Then for point each and every node, I need to create new. Again, further, I need to create a linked list. So let me take like this. Let this size be v itself. We let it be like that. Now I created. Now I will come here. I will write a code like void returns nothing to me. Add link. I need to add a link. Then here I will ask for the user for both u and v, right? Then what I do, ADJ u will be is push, same thing, push back v, then ADJ, then v dot pushback. I am directly creating this. I am not asking for is a direction or not. Can do that one. I think some if and else statement, if you use it will work. Now I need to print. So here I need to create an object. So graph is my class name. So let me call it as g, like g. I need to pass a value. That means five vectors. What is I have, right? I need to pass all the links for that one. So like 1 2, right? You know, right? 1 2 2, like this I need to pass. So 1 to 2 I have a vertex, sorry, link. So let me copy. I have 7 word links, I think. So let me copy paste. So you can optimize this for by using for loop. I am just showing you how it works. So from 1 to 2 there is a, from 1 to 3, 1 to 4 I think. Then where? Then 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 3, like 2 to have for 3. Then for 4 to 2 to 3 I have 2 to 3. Then 3 to 4, 3 to 5, 3 to 4, 3 to 4 and 3 to 5. Then for 4 to 5 I have, right? That is what. Now we are going to add. Then I need to print. For that I am going to call again a function. Let me call it as a print. So print what? Print, let me call it as anything like print the, it is a non-directional graph. So function name can be anything. So while printing you take nothing, then go there, then you need to print all the things, right? So let me take a variable I, right, for int. See, for every linked list, for node of the linked list, I need to traverse through its own linked list. That means what? I need a iterator because I am working on linked list. Sorry for this. So now iterator will be equal to, so I will, it is ADJ, right? ADJ, I need to ADJ. Then what? Then for again, see, I need to create a for multiple for loop, right? For I values varies right? For I values varies. For int I is equal to, it is going from where to where? 1. I less than equal to, so I have 7, right? I have 7 links, so let me take it as 7 I plus plus. So for j auto auto j, it is an iterator. So at adj, then that adj is I. So for that I you need to go from begin, right? Then j isn't equal to adj I, then n, then j plus plus. So if you do it must work, then I need to, what I need to do, I need to print, that's it, right? So what you will print, it is an iterator, so just print j like this. Can I print? So it should work. But if you remember that I need to print this I also, right? So there I did the same thing, I will do here the same thing. So let me give some arrow mark here, so it will print. Then after that I forgot end line in the previous code, so I will add that one here. So let me run, let us see what are the again I need to call print function, right? So I will call this, and it should be good to run. Now if I run, I'll get some error. Let us see what are the error. Add link was not declared in the scope. Add link, okay, this is a g dot, right? It is a what, it is a again object I need to key like this. So g dot, then g dot, you can do with even without using class and objects, it is fine, or you can stick it to the vector. Now when I run, did I ask for anything? See, the problem is I think I have not asked any number of nodes. No, I already, so it is returning me nothing. So let us see what are the mistake I have done. So I'm calling this, and it will go here. So will be initiated to this one. I'll create this one, then add link. After that I need to call, then push back this one. Then I took a pointer, right? I think everything is fine. So it will go from 1, right? 1. So 1 I need to, so for 1 I need to take till end, I need to go and equal to, then end line. So it will go till 5, I think, because number of nodes are what, 5. Let me run this, let us see is there any mistake here. I should get directly answer, that's it. So I think I don't get here because I did something mistake. Let me pause the video. So the problem was so much simple. Again, here I need to add v plus 1, right? As I said earlier. So this size was what my problem was. I need to go, this size, it is starting from 1 for me. So if it is starting from 0, so it will work. Definitely it will work. There is no doubt in that. So the problem was I needed to add plus 1. Actually I had it here, the plus 1, but I forgot. So let me run this one. So we're getting the result. So let us see the same thing we are getting or not. So we are getting the same thing. So so the size, the memory was my problem. So next video I'm going to cover adjacency matrix. So thank you.